Hello, welcome to today's webinar, The Power of Controlled Lighting. This is the first webinar of a six-part series designed to help print and packaging professionals tackle color accuracy. My name is Ed Hattenberger, Senior Color Scientist at X-Rite, and I will be leading today's session. Before we begin, if you have any questions throughout the presentation, please use the chat function to submit them, and I will do my best to answer as many as I can at the end. If we run out of time, an X-Rite team member will contact you afterward. So let's get started. Color plays a critical role for printed materials, influencing consumer perception and purchasing decisions. Whether it's luxury goods or everyday items, accurate color ensures your products stand out while maintaining brand integrity. Incorrect color can suggest a product is outdated or even counterfeit, an outcome no brand wants. While instruments and software provide precise color measurements, visual inspection under standardized lighting conditions is equally important. The print industry has established guidelines that align visual evaluation conditions with instrumental measurement standards, ensuring consistency across the board. ISO 36864-2009 specifies the graphics industry's viewing conditions, perfectly aligning with ISO 13655-2009's M1 measurement condition. Together, they ensure your visual color evaluation of physical samples will agree with the measured differences. Production areas must use properly maintained viewing booths, replacing lamps per the manufacturer's recommended usage hours. This ensures consistency in lighting conditions, critical for accurate color judgment. Beyond the press, quality control teams often rely on dedicated viewing booths to simulate various lighting environments, such as D50 daylight, store fluorescent lighting, or traditional home incandescent lighting. The impact of lighting on color perception is significant, as lighting conditions dramatically influence how colors appear. For example, D50 daylight, with its balanced light energy across the visible spectrum, delivers natural color accuracy, making it ideal for evaluating print. In contrast, cool white fluorescent lighting introduces an excess of yellow-green light, which alters red, blue, and green hues. Similarly, home incandescent lighting, with its strong yellow-orange bias, tends to dull colors like blue and green if you look at the sky and grass in the bottom image. In the print industry, proper D50 lighting is the standard for accurate color evaluation. This is because common facility lighting often has color biases that distort color perception, leading to inaccurate judgments. Just think of all the different lighting you have in your facility. Everyday lighting simply cannot provide the precision required for reliable color assessment. Now let's talk about metamerism. Metamerism occurs when colors match under one lighting condition, but differ under another. This can cause significant issues, especially for products with components produced under varying printing conditions. For instance, a folding carton and an attached label that are printed with different ink pigments might appear consistent under D50, but shift in different color directions such as store lighting. Proper ink formulation and visual inspection under multiple lighting conditions can help prevent such mismatches. The image on the screen shows an example of a metameric pair. This D50 lighting indicator sticker from Pantone is designed to help identify proper D50 viewing conditions. The top and bottom halves of this sticker are formulated with different pigments to visually match under D50 daylight, but they do not match under other lighting conditions. We will use it to illustrate how metamerism works. If we measure the top and bottom halves, our software displays the results. The graph on the left shows the LAB measurements for the two color samples with a tolerance ellipse drawn around 2 delta E 2000, a common industry tolerance. The LAB values are very close, indicating a match under D50. On the right, we see the spectral curves, which do not align well and cross over several times. This crossover suggests that the colors will not match under different lighting. So while the top and bottom half visually match under daylight D50 conditions, if we switch the light booth to fluorescent store lighting we see that the colors do not match in that lighting. The fact that the curves cross over each other several times is a good indicator that these colors will not match under different lighting. Viewing the printed sample can further validate whether the color change is acceptable. If this color were used on a cosmetics product, would such a shift be acceptable? Another consideration is the use of optical brighteners in our paper. Many papers, carton boards, and even some printing ink pigments use optical brightener additives, also known as OBAs, to appear whiter and brighter. These agents absorb invisible UV light and reflect it in the visible blue range. Having a UV light source is essential for understanding the impact of optical brighteners on samples. On the screen, you'll see two pictures of the same graphic reproduced on a folding carton next to an inkjet proof. In the image on the right, under UV light, we can observe that the production stock contains optical brighteners, while the proof does not. Another important consideration is how we perceive color. Surrounding colors significantly influence our perception, making consistent evaluation procedures essential. For example, take a look at the front middle square of the cube. What color do you see? Now, compare it to the top middle square of the cube. How would you describe that color? They appear to be distinctly different colors, don't they? They are actually the same color, but the surrounding colors impacted our judgment. By isolating colors during color evaluation, eliminates optical illusions that may skew judgment. Look again. You cannot force yourself to see these as the same color, even if you know that they are. This happens all the time. So when judging color, isolate colors to eliminate optical illusions that may skew judgment. When practicing visual evaluation, it is important to have a defined procedure that everyone can follow. Here are some best practices. First, to ensure accurate alignment with the latest measurement standards, it is essential that lamps and fixtures comply with ISO 3664-2009. This compliance will enhance the correlation between measured color differences and visual color differences. Additionally, ISO specifies the use of a D50 lamp, which includes a defined amount of UV light to maintain consistency in color evaluation environments. Next, it is important to use neutral surroundings. As we saw with the cube example, a neutral backdrop prevents external colors from influencing judgment. Third, to optimize viewing angles, position the samples at a 45-degree angle to reduce glare and ensure optimal viewing conditions. If your booth is set up like the example on the left, users may need to adjust their height to achieve the best angle, which can be challenging. The setup on the right, however, allows users to easily adjust their viewing angle by simply stepping closer or further from the booth. It's also beneficial to test the viewer's color discrimination. One commonly used test is the Munsell FM100. In this test, the user sorts color tiles that feature subtle differences in color, positioned between fixed reference tiles at the ends of each strip. The results are scored and displayed in a graph. If the graph shows only minor bumps near the center, it indicates normal color discrimination. However, if larger spikes appear, this suggests the user struggles to distinguish certain colors. For example, if there are prominent spikes in specific areas, such as yellows and blues, it would indicate the user has difficulty accurately perceiving these colors. Lastly, to maintain physical standards, it is important to replace color guides regularly to prevent fading, dirt, and wear. The use of digital standards help ensure long-term consistency and complement these physical standards. Let's discuss the limitations of physical guides further on the next slide. While physical standards are a good tool, it's also crucial to understand the limitations these guides present. Fan decks and other printed guides are typically produced on printing presses, which inherently introduces some natural variation. Despite being manufactured to strict tolerances, no two guides will be exactly the same. Inkroom proofs can also exhibit inconsistencies. particularly across different sections of the proof, which may affect color accuracy. With light standard dark guides, it's essential to recognize the potential for user subjectivity. The light and dark examples are designed to mark the boundaries of acceptable variation, not optional targets. As discussed as the previous slide, physical guides are also subject to wear and tear. Over time, they will fade and can easily be compromised by fingerprints and dirt, further reducing their reliability. Given these limitations, it's imperative to maintain digital standards such as Pantone Live. Digital standards ensure consistent quality control and allow for accurate measurements using instruments, helping you achieve precise and repeatable results in your color evaluation processes. Controlled lighting is foundational to color quality control, reducing customer rejections and improving product perception. By following these best practices, you'll ensure your team is equipped to meet the highest industry standards. We are excited to announce the recent launch of our latest innovation, the Judge LED Light Booth. This state-of-the-art product offers instant warm-up time, stabilized illuminance for consistent color evaluation, and an eco-friendly design that reduces energy consumption. The Judge LED Light Booth is equipped with multiple LED light sources, including D50, D65, and more, ensuring the most accurate color assessments possible. Visit X-Rite.com to learn more about the Judge LED Light Booth and other controlled lighting solutions. Now, I'd like to spend some time going through the questions we've received during the webinar. If you have any questions and have yet to submit, please send them using the chat function. I will take time to answer a few, but if we don't cover yours today, an X-Rite color expert will contact you. If you would like to speak to someone about your color evaluation needs, we will display a survey immediately following the webinar. All right, the first question that came through says, you mentioned the new LED viewing booths, but we currently have fluorescent booths. What is the ideal type of viewing booth for accurate color assessment? So, for accurate color assessment and printing, it's essential to use controlled lighting that closely simulates natural daylight, such as D50, 5000K. While fluorescent booths are cost-effective, initially they have limitations. They require more frequent lamp replacements and don't match daylight or other standard illuminance as precisely. LED viewing booths offer greater flexibility, providing more accurate simulations of daylight, incandescent, and fluorescent lighting conditions. Additionally, LED systems consume less energy, require no warm-up time, and offer longer lifespan. Some incandescent-based systems can deliver highly accurate daylight simulations, but they tend to be more expensive and consume more energy. LED booths strike a balance, offering lower cost while delivering more accurate lighting simulations, making them an ideal choice for color assessment. The next question asks, how long do the lamps usually last? This is really based on usage hours. Typical fluorescent lamps will last up to 2,000 hours, while LED lamp lifespan can be closer to 8,500 hours. Okay, I'll answer one more question today. The last one says, sometimes I have a hard time visually matching my proofs even when I am in my viewing booth. The proof was validated with an i1 Pro 3. Is something wrong with my lighting? The most common issue that can lead to a discrepancy between an instrument measurement that passes and a visual assessment that fails is the presence of optical brighteners in the proofing stock, but not in the press stock, or vice versa. This is where it is useful to view the press sample and the proof under UV lighting to see if either one glows. Most packaging materials don't have optical brightening agents, OBAs, so it's a good idea to make sure your proofing stock doesn't either. But if you're working with packaging that does have OBAs, you might want to switch to the M1 measurement condition in your software for press and proof validation. M1 measurements include the UV light that reacts with the optical brighteners to more accurately show the visual difference that the OBA will introduce. For those I didn't get to today, an X-Rite color expert will be in touch soon. Thanks again for everyone's time, and please stay on for a quick survey. Have a great day.